today's video, we are going to discuss the proficiency to operate specific function constituting task group for route monitoring. So since it focuses on route monitoring, we are going to create a route. But before creating a route, we must know first where we are going. So for example, our professor gave us 10 for our truck. So as you can see on your screen, our shallow depth is 10 meters. And you can put any meters for the other two. After that, click apply. So you can see the contour lines on our map. We are going to discuss first the contour line. So what is contour line? Contour is the line that connects the equal depth. This video will help to understand the best practice for handling safety settings on Ecdis, which includes the safety contour, shallow contour, and deep water contour. We are going to discuss the different contour that I mentioned earlier. The first one is shallow contour. On your screen, you can see what shallow contour is. It highlights the gradient of the seabed. It is considered to be the grounding depth. This is the depth below which the ship will definitely go aground. Right now, you can see the safety contour on your screen. It is the most important parameter of all the safety settings for the display of the unsafe water areas, detecting isolated dangers, and triggering anti-grounding alarms. We can see here the safety depth. So, what is safety depth? Safety depth is normally the ship's drop plus squat. It is also the area where we can navigate. The purpose of safety depth is to portray spot soundings, either in gray for deeper depths or black for shallower depths, compared to the safety depth value, highlighting the potentially safe and unsafe area. The last one is deep water contour. This is normally set to twice the ship's draft. However, navigating officer can use deep water contour value the way they want. Ecdis also gives the option of simple two-color shading. In this situation, light blue and deep blue will merge into a single blue color, and gray and white will merge to a single white color. If the value of safety contour is changed, the boundary between two depth shades changes accordingly. Now, let's proceed on the tools on our Ecdis that we can use to aid navigation. For example, our ship is here, and we want to make a course going to 270 degrees. We are going to start here, going to 270 degrees and 5 nautical miles. So since we are already done with 270 degrees and 5 nautical miles, we can use tools so that our route is safer. First, let's click OCP and draw. So since we are here, it is possible to see our distance of one object or terrestrial body. So for example, the captain asks you to get the fix. We can use this tool called EBL. We just need to click Create EBL. Then place the cursor to the location you want to get the distance. So for example, it is here. You are from 307 degrees to 127 degrees and the distance is 21.1 nautical miles. So that is the purpose of EBL. The next one is PIL. PIL means parallel index line. Our course is 270 degrees. So let's click here. Parallel index line's purpose is to monitor our ship if it is in the right course. So for example, let's move the line here. Now, you can see on the screen the measurement of our PIL or parallel index line. We can see here that our ship is in 270 degrees. So through the help of PIL, we can easily see on our Ecdis if our course line is fast and if we are on intended track. The next tool is range ring. Just like on our previous video, we can just select the number of ring that we want. So let's try 5 rings. And the distance of it is 5 as well. Click apply. So this is how it looks like. You can see on your screen the 5 rings that we selected earlier, as well as the distance of it. So let's try other tools. The next tool is our DR. We can create our dead reckoning. So for example, our speed is 5 and our course over ground is 270. Our DR path is 5 nautical miles. So for the DR point interval, we can choose if we want time or distance. For now, we are going to choose time. Let's change our speed to 2. So we can see now our DR. After that, click OK. So on your screen, you can see now our dead reckoning. We can also see our dead reckoning by clicking OCPN Draw Manager, then DR and Properties. So on your screen, you can see all the details about our dead reckoning as well as the bearing, latitude, longitude from one point to another point. That's all. Thank you.